Hey guys, I just realized I've been kind of neglectful in my duties. I'm sitting here, it's actually midnight. I'd show you the clock, but oh, you can see the clock right there. But I haven't actually done any ground level performance tuning stuff, so that's what we're going to do tonight. It's going to be a little rough because I haven't rehearsed this, but you know, that's what you like about us, right? So, a very brief introduction to tuning queries. We've got a query here that we want to know how it's doing. So, first thing we're going to do is run it. You may not always have that option, but it's certainly nice. That came back pretty fast, sub-second. But we want to know what it is that's going on, behind the scenes. The first thing I want to introduce you to in SSMS is the estimated and actual execution plans. Now, with estimated, you can just highlight your query and hit it, and it won't run your query. It'll just give you the estimated execution plan. And we'll talk about the execution plan in just a minute, so don't freak out. The actual execution plan is a button that you toggle on, so when you execute your query, then it runs your query and gives you the actual execution plan. So let's look at the plan itself for a minute. It's a little tab you get down here. It'll give you the query cost relative to the batch, and we'll look at that closer in just a couple of minutes here. Give you the actual query. When you have a really long query that won't fit on this line, then you can just hover over it, and it'll give you the whole query right there. And then down here you can see what actual steps that we're doing behind the scenes. And in this case, all we're doing is a table scan. Now, first rule of tuning: table scans are bad. It's exactly what it sounds like. If you can think of your table as a book, to find what you want, we're starting at page 1 and scanning up and down every single page until we hit what it is that we want. Not at all efficient, so we'll be looking at how to address that in a second. A couple other things. Execution plans they're very deep. Grant Fritchie wrote an entire book about them. People have written long chapters and sections about them. But the very basics, you have little icons that show you. There are different kinds of icons that show, for example, joins, scans, index searches, and so forth. And if you hover over them, then you'll get some great amount of information: physical operations, actual number of rows, estimated costs, and so forth. Again, we're not going over all that tonight because this is kind of a ground zero. One thing that's pretty cool, this little arrow that shows this is the direction that the data is going. The arrow gets wider the more rows that you pass. So, you get these really, really fat arrows if you're passing a lot of data. And this is a medium-sized one. We're only passing 150 rows across. And then you start off with your actual operator. And you generally read execution plans right to left, because that's the direction that the data is going. It goes out and it gets all your table scans and so forth on the far right. But that's all I really wanted to say for now about execution plans. So, okay, great. We ran it. That's fabulous. Maybe if we've got a table scan, we should find out a little bit more about the actual table that we're working on. So you can use SP help to bring back... Oh, sorry, I forgot. I've got my toggle button on, and I don't have show plan permissions for master, which don't worry about that. SP help is a master database stored procedure, and I don't get to see the execution flash for that. Moving on. You want a little bit of information about your table. This SP help is a beautiful and time-honored way to get it. Name, create date, all of your column information, just beautiful. We do have an identity column on there. That's great. Something that you need to see here is that we're not seeing something. We're not seeing any indexes on this table. This table is what we call a heap. So a very good first start, in my particular situation especially, would be to go in and add a primary key, clustered primary key constraint to my identity column, because that's what I want the primary key to be on in this particular case. I'm often joining and searching off of the ID. and it's a good choice. So I'm going to go ahead and run this, and oh, I didn't expect that to work. Oh, that's right, because it's already I did this a little test table, and I got an error back saying that you can't put a primary key on a nullable column. And I said, oh, well, I'll have to include the alter table so that it's not null in there, forgetting that ID, as we saw earlier, let's show it again, is an identity column, and identity columns are by definition not null. Anyway, so moving right along, Fozzie, we just created a primary key. Beautiful. So if we go through and we say, okay, toggle the execution plan, execute my query, look at the execution plan. Ah, great. Now we're getting a clustered index scan. That's much better. Nah, not really. All that is saying that now instead of scanning the entire heap, we're scanning the entire table, which has a primary key on it. So, whoop-de-doo. To recap, because I had to pause and I forgot where I was, a clustered index scan, really not any better than a table scan, because you're still doing a full scan. You're starting at the beginning, you're looking until you find what you want, and then you stop. Now, if we really want to help this query, and depending on your business needs, you can't always do a magic fix like I'm going to do here, but we're just doing this because we're at level 0 and to show how great this is. We've got an index on the ID column, yes? So why don't we search specifically for a particular ID and see the difference? So select star from video, and by the way, select star is bad, don't use it. It's just for academic purposes. Okay, select star from video where ID equals, I don't know, 88. So let's run that. That's already toggled on, good. So we got our one record, and a clustered index seek. Now notice, by the way, if you didn't before, here let's run this and the previous query side by side so I don't have to switch back and forth. Like that. And execution plan. So see, you've got two queries in the batch now, and you can compare them. So first thing I want you to look at is select star from video gets you a clustered index scan, and select star from video where ID equals 88 gets an index seek, and there are different icons. It makes it very nice as you're scanning through a really big execution plan to go, aha, there's a big L arrow, and that's bad. That's something I should look at. Anyway, the other thing, by the way, that I want us to look at is we mentioned query cost relative to the batch. So we put two queries in the same run, and it shows us how much of an overall cost this query has compared to this query. This query is much better. It only took up 31% of the batch as opposed to this query being 69%. Now, if you ask me specifically, well, how is query costs calculated? I honestly don't know, and for all intents and purposes, this really is just a guiding light. You can't say, well, 69%, it is exactly that much better, do the math, 19% twice, so whatever, that much worse than this one. But it gives you an overall picture of, this one is better and this one is not as good. And you can get hard and fast numbers, and we'll cover that in later lessons, but for the time being, yay, we can compare two different queries, and it's great when you run, say, a dozen queries, and you scroll down and you see one of them taking 90% of the batch. You're like, wow, well, that's the one I should probably focus on, and it's usually right. It's a good place to start. Okay, so getting back to the matter at hand, we added a where clause, which, gave us a completely different result set, of course, but we're just talking performance. Yeah, if you can get specific information as opposed to, say, all the information in a table, it's going to be better. If you can get a specific set of rows by seeking for them as compared to the same rows by scanning for them, and again, we'll cover that in later videos, what contributes to that. Seeking is always better, it's quicker, it's targeted, it's good. So, back to the book example, we've gone over what the scan is, but with an index, you have like an index in a book, and you can look it up, in the case of a book, alphabetically. Okay, clams, C, okay, go C, L, C, L, C, L, A. Okay, there it is on page 44, boom. We found it, as opposed to having reading through pages 1 through 44, skipping the introduction and so forth. So what have we learned today? We have learned that queries should always tell the truth. No, initial steps for tuning a query. Let's see how long it takes. Let's see what kind of execution plan. Do we see any scans? Let's take a look at the table itself that's involved using SP-Help, see what kind of indexes it has on there. Definitely want a meaningful, useful, narrow primary key, something that can get searched on, something that's unique. And if at all possible, we want our queries to seek and not scan. So that's our lesson for today. Very introductory stuff. If I've been unclear on anything at all, please write me and say, Jen, refilm this because you didn't cover this or that, or you should cover this in your next video. And that's it for now. Happy days, guys.